Good afternoon. So what we're going to do, we're going to go over the practice test number 3. You have to read a couple of questions from your quiz. I will look at your quiz and grade it by tomorrow. Especially there is one question on the relative maximum, relative minimum. We give you that one, okay? But otherwise the rest are going to be like this one. Okay, you get a couple of questions like directly finding the double integral or triple integral as in your quiz. And the rest are going to be the following, okay? So I'll give you an idea of the type of the topics that we are going to be interested in for this test. And this test will be repeated on the final. Okay, so these are going to be the concept for the test number 3. So that would be your practice test. Okay, number 3. So the topics that are going to be covered, okay, we give you the first topic is going to be, we give you one problem in applying the second derivative test to find the, okay, this would be apply the second derivative test. Okay, like your quiz, derivative test. Okay, to find the relative. Okay, find relative extreme. Okay, extreme of a function. Okay, a function z equal to the f of x, come on, like your quiz. So there is, just check this one from your previous quiz. Then you are going to have evaluation of, okay, evaluate just a standard one, evaluate double and triple integral, triple integrals, like your quiz, okay? So the region and the limit of integration would be given to you. You don't have to determine those, and you can do it, you know, right away. This is it. The number 3, we are going to evaluate double integral, reversing the order. Evaluate double integral, integrals by reversing the order. I'm going to take this today. Sometimes the integral is impossible to find. You have to reverse the order. Of course, you are going to reverse the region of integration from type 1, for example, to type 2, and you integrate it. Okay, that would be number 3. Number 4, we want to evaluate double integral. Evaluate double integral using a polar coordinate. Okay, using polar form, polar coordinates. Need to check it. Okay, that's it. Then number 5, we wanted to find the surface area. Okay, you know, surface is going to be the graph of a function of 2 variables. Okay, and you would like you to find the surface area, the area of a surface, the area of a given surface. Okay, surface is going to be the graph of this type of function. Okay, so the surface area problem. And you have the formula, and you're going to do it, and we have it over here, and we're going to check it for you. Okay, so that would be the surface area. Then we go to the triple integral. One would be given to just evaluation 1, but you have to find the triple integral. Okay, that's it. Triple integrals in cylindrical form. Okay, cylindrical form or cylindrical coordinates. Cylindrical coordinates. And then, of course, triple integral in a spherical coordinate. Triple integrals in spherical coordinates. Spherical coordinates. Okay, so one from each would be given to you. Then we would like to, you know, find the volume. find the volume of a three-dimensional solid, volume of a three-dimensional, let's say a solid. You know, you can use the double integral or you can use triple integral. You are going to be able to use each one of them, whichever is going to be better. Okay, so these are mostly the topics that you're going to see. Maybe you give you, it's going to be 8 or 9 questions, and then there's going to be one extra. Then you can do all of them as usual, or just do the one that you've been asked to. So these are the topics, and all of them are here. Just get practice, make sure you are able to do it, okay? And all of them would be repeated on the file. So the first one is study your, the one behind your quiz or the practice quiz that you have. This is the one we did it. Okay, there was one on your quiz. I check it tonight, by tomorrow, and I post a solution for you. You can, can check it to make sure you get it right. So we are going to go to we have all of them over here, one by one. Okay, that's it. So the first one, we are going to do reversing the order, okay? It's going to be quite, not a difficult one. You have to make sure that get the limit of integrations correct, okay? So this is going to be question number 1. Okay, that's it, number 1. Evaluating integral. Okay, that's it. Evaluate each integral. It's a double integral. Okay, each integral by reversing the order. We give you the hint that we would like you to do it by reversing the order. Okay, you have a couple of them over here. You can do all of them quickly. Just give you the idea, and one of them will be given to you on this test and on the final. Okay, part 1. Part 1, the integral is 0 to 1. Okay, 0 to 1 for y to 4. And the function is e to the x squared dx dy. As you can see, e to the x squared, it cannot be done, okay? Because the result is not going to be kind of elementary function that you'll be able to find it. If you want to do it, this is x squared. By u substitution, you need the 2x. You don't have the 2x. So it's not advisable, if you like, to integrate it as is. So we'd like to change the order. You have to look for the limit of the integrations and to see how we're going to, because when you change the order, you have to change the limit of your integration, okay? So you check to see what you have. The information that you have is this one. Okay, so y is solution. So you remind yourself that your y is between 0 and 1. Okay, and your x is between 4y and 4. You see, this is the situation we're going to have. And so what we do is we let x to be equal to the 4y. That is the function that's given to you, and you solve for y. You change it to the y equal to 1/4 of x. Okay, because you need it and you change it. And so you identify this region that you have. Okay, just using the number that you have, 0 and 1. So this is a situation so far. This is going to be x, y. If you put y equal to the 0 over here, x would be 0. It's going to be a line. If you put y equal to 1, so x would be 4. So you identify these points to get the line. So you go from 0, 0. This is going to be 0, 0 to 4, 1. 1, 2, 3, 4, and 1. Okay, so this is a situation that we have so far. Okay, in this region, this is 0, and this is 4, and it's 0, 1. So the region in question that they did it is 0, 1. So this is going to be 0, 1. And they replace x by a function. Okay, so in this case, the way they did it is they go horizontally. You see the x to the right, to the left, right, left, right, left. So the right is 4, which is on the top, and the left is this function. Okay, the left is this function, which is x equal to the 4y. So what you have to do, you have to switch it. You switch it, the graph would be exactly the same thing. Okay, I just show you here. So your graph is going to be the same. So this is 0, this is 4, and that is 1. Okay, so this is going to be the graph. So what we are going to do, we're going to change it. In this part, they fix the y. So we are going to fix the x. Going to the right, to the left, your x is going to be between 0 and 4. Then they go right to left to get the x. Now you have to go up and down to get the y. You see up, down, up, down, up, down, up, down. So your y down would be x-axis, which is 0. Up would be this line. And you have to solve for y, and you already done this one. So the line is y equal to the quarter of x. So y would be between 0 and a quarter of x. Any question? So that region was type 2, if you like. You see, this is the type 2 region, and you change it to the, okay, to change it to the type 1. The names are not important, just be able to do it, and that would be, we are going to be happy. Okay, so we are going to change the integral. This is it. We reverse the dy dx, and in this information that we have, so the original integral, you know, we can repeat it or we can call it I. It doesn't matter, okay? So if you want to repeat it, this is it. You have the 0, 1, 4, y, and y, e to the x squared, and dx, dy. This is the original one. Now you're going to change it. You change it into, that's going to be e to the x squared. You integrate with respect to the y first, then the x. Your y now is going to be between 0 and a quarter of x. Okay, and your x is between 0 and 4. Okay, now it's easy to integrate because the integral of the first one, it would be just 1. So this is going to be equal to the 0 to 4. Okay, y e to the x squared, and y going from 0 to a quarter of x. And then when you come back, you integrate with respect to the x. Okay, substitute. The bottom one give you nothing, and the top one give you, okay, so you end up with the 0 to 4. 0 to 4, a quarter of x times e to the x squared dx. That's it. Now we are ready to integrate it. So what you need is going to be, you need a 2x here, okay? You need the 2x here to be able to do it. So if you pull out the quarter out, so that gives you 0 to 4, x e to the x squared dx. You can use the general u substitution if you like. You see, u, if you take the u to be x squared, then your du would be 2x dx. You can find it and go ahead, but I just multiply the, okay, I'm going to divide by 2, and I multiply it inside by 2. So that give me e to the x squared times 2x dx. So I created, you know, I created the u and du. So it's like integral of, so that would be 1/8. Okay, 1/8 e to the x squared, and it's going from 0 to 4. Okay, 0 to 4. And, you know, just substitute. You may use your calculator. It's going to be 1/8. It's going to be 1/8 e to the, if you replace the x by 4, so that give e to the 16 minus, minus 1/8. This would be the final answer. If you like, you can use your calculator. Otherwise, leave it as is, or, you know, it's optional. It's going to be e to the 16 minus 1, the final answer, and be accepted right away. Okay, so that is, you know, it's not a difficult problem, but you have to get the graph of the first one and to see when you switch it, what would happen to the leftover. That's part 1. Any questions? Okay. So, you know, we can do one more for you here. All of them are, these are the most popular one that you can see. Okay, are you done? Going to the part B, they give you quickly one more. This second one is very important, very famous integral. Okay, so the same thing, same instruction, reversing the order, and you want to do this integral. Okay, integral of, this is the problem. Okay, 0 to 1, x to 1 sine y over y dy. So this is going to be the case, 0 to 1, 0 to 1, x to 1, sine of y over y, and the dy dx. You see, as you can see, this is impossible to find. You cannot integrate with respect to the y first. It's not possible. So you would like to switch the order, get to see what we have. The integral with respect to the y and the x. So this is it. Your x is between 0 and 1. Okay, and your y is between, this is going to be your y. Okay, again, you get this one. You need it to be equal to y equal to the x. Now graph this one. The point that you can use are going to be 0, 1. So this is it, x, y. If x is 0, y would be 0, 1, 1. Okay, so if you graph this region that is given to you, this is it. You have the 0, 0 here, and then you have the 1, 1. So this is going to be the region. Okay, so the region in question is going to be x is between 0, 1. So x is between 0, 1, and y is between, see, y is between the x. So the bottom one is y equal to the x. This is the bottom one. And the top one is y equal to 1. Okay, y equal to 1. This is y equal to 1, if you like. Okay, this is y equal to 1. So the region in question is this part. Okay, that would be the region. X equal to 0, 1. And the way they did it, they just, again, they go up and down to get this part. So we have to switch it. Okay, that's a kind of a type 1. We are going to change it to the type 2. So what we do is you bring this one down. So the graph is going to be the same one. This is going to be the graph. You have the 0, 0. You see, you have the 0, 0. And you have the 1, 1. This is 1, 1. Okay, and this is the line that we did have. So what we are going to do, we're going to switch. They fix the x here. Now you have to fix the y. So we fix the y between 0 and 1. You see, this is it, y equal to the 0 and y equal to 1. Now, and then you have to get the x going to the right, to the left. See, right, left, right, left, right, left. For the x, if you go to the, okay, if you go to the right, this is going to be your x. So your x is going to be, okay. So the situation that you are going to have for your x is going to the right, to the left. Okay, this one is the y-axis, which is x equal to the 0. And over here is going to be just x equal to 1. Okay, so y is between 0, 1, because you go up and down. So for the x, you go to the right, to the left, you see, right, left, right, left. So the bottom one is going to be the x-axis, the y-axis, which is x equal to the 0, and the right one would be x equal to y. Okay, so as you can see, this is a type 2 region, and we change it to the type 1. Any question? So go back, reverse the integral. So integral was 0 to 1, x to 1, sine of, okay, sine of y over y dy dx. You change it into, you reverse this one, so that give you sine y over y dx dy. Now x going from 0 to y. and then y going from 0 to 1. That's it. Now the integral is very easy to find because the integral of this part will be just x. So it's going to be 0 to 1. Okay, 0 to 1. You have a sine y over y x. And x going from 0 to y. And when we're done, we integrate it with respect to y. Okay, if you put x equal to 1, x equal to y, 0 to 1, sine of y over y, y. And if you put the 0, that gives you 0. Okay, 0 dy. Now the y and y would cancel out. So the leftover is going to be 0 to 1 sine y dy. And integral of a sine is going to be negative cosine. So the negative cosine of y from 0 to 1. If you substitute that, give a negative cosine of 1 minus cosine of the 0. Cosine of the 0 is 1. So that gives you the result is going to be negative cosine of 1, okay, plus 1. The final answer. You write it down as is. You can use your calculator if you like to get the value, but you don't have to. Okay, so this is how you change it. You got to be careful. Okay, but you have to graph it. Okay, don't memorize anything. You graph it and then you get that one right away. Okay, that's part B. Any question? Now part C is a little bit tricky. Let's do the part C for you. Okay, that give you experience and you'll be able to do it, whatever we give you. Okay, so what is part C? You see the part C is this function, this integral. We want to find integral from 0 to ln 10 and e to the x to 10, 1 over ln 1. So this is going to be part, okay, part C. Part C, you want to find this integral 0 to ln 10, okay, ln 10 and the e to the x to the 10. And you have 1 over ln y dy dx. Again, you see, if you want to integrate as is, it's not possible. You won't be able to do it for the u substitution. You don't have the u prime. To be able to do it, you see, u prime would be 1 over y. So we want to reverse it, check to see what we have. So over here, this is it. They start with the y. So you have the fact that the y is between e to the x and 10. Okay, and then your x is going to be between 0 and ln of 10. So this is what it's given to you. Okay. Now let's see what's going to be the shape of the graph. The shape of the graph over here, this is what you have. You can work on this one first. Okay. So you have y equal to the e to the x exponential function. For the exponential function, use these two numbers to find the limit of your, okay, when you want to graph it, the limit of the graph, if you like. That's going to be x, y. If you replace x by 0, e to the 0, okay, e to the 0 would be 1. And if you replace x by ln 10, you know that e to the ln 10 would be just 10. Okay, so it's going to be part of the exponential function, okay? So this is going to be the region in question. So get the exponential function. You see the point that you have are 0, 1. This is going to be 0, 1. Then you have ln 10 and 10. You can guess what's going to be ln 10 with your calculator. Suppose this is going to be ln 10. When x is ln 10, this is 10. So you get 10 here. So this is going to be your situation, okay? And you know that the form of the exponential function is this. Okay, this is going on forever. That is the graph of y equal to the e to the x. Okay, identify the region in question. So the region in question is going to be part of this graph. that is going to be between x equal to the 0 and ln 10. Okay, and this is it. X equal to 0 going to be the y-axis, and x equal to the ln 10 is this one. So the region in question is this. Okay, this is going to be a region. The way they did it is, or they suggested, they fix the x to go to the right, to the left. In order to get the y, they go up and down. You see, they go up and down, up, down, up, down. So you have to reverse this one. You have to reverse it, fix the y, which is going to be between 0 and 10. Then you go to the right, to the left. So let's see what's going to be your result. So your result is going to be, it's going to be the same graph. Okay, this going, we can check it over there too, quickly, but I'm going to re-graph it if you like. This is going to be ln 10 that I have. Okay, and that was the one, and this is a 10. So this is a situation that we have, okay? Remember, that's 10. So what we'd like to do, we have to reverse the order. And they fix the x, now we have to fix the y. Going up and down, up, down. You see, up, down, 1, 10. So your y is going to be between 1 and 10. So for your x, you have to go to the right, to the left. You see, right, left, right, left, right, left, right, left. Now, the situation that we're going to have is your x is going to be to the right, to the left. Okay, to your right is going to be just the x-axis, which is going to be 0. So you have to find the other side. The other side is going to be this function over here, which is going to be, you want the x. Remember, you didn't have y equal to the e to the x. Y equal to the e to the x, you have to solve it for x, you see? Y equal to the e to the x, you know that. The inverse function of the x would be ln function. So that gives me x equal to the ln of 1. So this is going to be the case. So that's a point about this one. For the other problem, remember, you solve for x, you solve for y. But for this one, this is the way you're going to solve for x. So y equal to the x, e to the x, so x would be ln y. Any question? So this is the point about this problem. Okay, then we are ready. So just bring the original one and switch. So the original one is this one, 0 to ln 10. Okay, e to the x to the 10. And that's a 1 over ln of y dy dx. Now switch. And this is it. The way we're going to switch it is going to be, this is 1 over ln y. But we go with the x first, then the y. So our x is between 0 and ln y. Okay, then this is x, and the y is between 1 and 10. 1 and 10. Now you integrate, because the integral of the first one will be just x, because this is considered to be constant. So we get the 1 to 10, 1 to 10, 1 over ln y as is, but x. Now x going from 0 to, okay, ln y, and when you're done, we come back and integrate respect to the y. Okay, any question? I'll substitute, put x equal to ln y, that give you a very easy integral to y. So it's going to be 1 to 10, 1 to 10, we have 1 over ln of y, times it by ln of y again, okay, minus 0. Minus 0 dy. So these two would cancel out, get only 1. So it's a 1 to 10. 1 to 10 dy. And integral of dy is just y. So y 1 to 10. So that gives you 10 minus 1, which is a 9. So the final answer would be 9. Okay, this is very interesting case because when you do that inverse, okay, you must know that the inverse of the, okay, know that the inverse of that exponential function inverse is going to be, okay, ln function. Okay, so that's a one. Any question? You have one more. Again, that inverse function of the other one is also important. So I'll give you this one too. And then again, you see, have to be careful about the picking the function. You see this one? I'm going to do the part D. You have to integrate sine of y squared. Again, it's not possible. You need u prime. So 0 to 1, x to 1, sine of the y squared dy dx. So I'm going to go to the next page and give you this part. And you keep these solutions because this is part of your final review, okay? So we're not going to do it again. So the part D, the function, the integral is 0 to 1, is 0 to 1, x to 1. X to 1, but sine of, sine of y squared dy dx. This is the case. Again, it's not possible to integrate respect to the y, so we want to switch the order, check to see what we have. Okay, the integrate respect to the y first, so the y is between x and 1. And then the integrate respect to the x is between 0 and 1. So get the graph, this is y equal to the x. The number to be used are going to be just 0, 1. So if you put the 0, 1, x, y, x equal to the 0, y would be 0, x equal to 1 would be 1. So get the graph of the region. And so that's easy because you have the 0, you have the 1, 1. Okay, that's a 1, 1, and that's the same line. This is it, this is the line, 0, 1. So the way they did it, it's a type 1, because the x is between 0, 1. And in order to get the y, in order to get the y, they go up and down. We get this part. Okay, so this is the way they did it. Up, down, you see, up, down, up, down, up, down. Because the down is y equal to the x, and the up is y equal to 1. This is y equal to 1. Now we want to reverse it. So we fix the y and we go to the right to the left. So this is going to be a situation when you change it. The region is going to be the same one, but the order is going to be different. 0, 1. This is 1. This is the region that we have. So we would like to fix the y. So y going from 0 to 1. If you go up and down, we get the 0, 1. Now to get the x, you have to go to the right to the left, you see? Right, left, right, left, right, left. And that's it. So the right is just the y-axis. In this case, x is 0. And the other side is simply y. Because we have y equal to the x, now you change it to the x equal to. So it's not a difficult region to organize, okay? So rewrite the integral and then do that. Any question? So this is it. So the original one is 0 to 1, x to 1, sine of the y squared dy dx is switch into. This is the sine of the y squared. Would you like it? Okay, y squared dx dy. So our x is going to be between 0 and y. Okay, and the y is between 0 and 1. That's it. Again, as you can see, you're integrating the first part, you integrate respect to the x, this would be just an x. And then that will create the u prime that you need for the second part. It's going to be 0 to 1. 0 to 1, and this is just x sine of the y squared. But x going from 0 to y, and then we come back and integrate respect to the y. Substitute x equal to y, x equal to the 0. So that gives you 0 to 1. Okay, y sine of y squared minus 0 gy. Okay, so that's it. It's going to be 0 to 1. 0 to 1. That's it. Y sine of the y squared dy. Again, you want to use substitution. If you take u to be y squared, okay, your du would be 2y dy. So you need a 2 here. So what we do is we divide outside by 2, and you multiply the inside by 2. 2y sine of the y squared du. So you have it. You see it's a 1/2 0 to 1 sine of the y squared, and this is your du. So it's like integral of a sine of u. Sine u, you see this is going to be, this is your du. This is your du, and this is sine u. So integral of a sine would be negative cosine. So negative cosine of the y squared. But y going from 0 to 1. If you substitute 1, negative 1/2 cosine of the 1 minus negative cosine of the 0. Cosine of the 0 is 1. Okay, there is a 1/2 here as well. Cosine of 0 is 1, so that gives you negative half cosine of 1 plus 1/2. The final answer. Okay, so this is kind of all the possibilities for this type of functions. Okay, that you reverse the order to be able to get a nice integral. Okay, this is the reversing the order. Any question? Yes. Yes. Okay, so we are going to continue. The next part is polar coordinate. Very easy case. Okay, this is it. A function would be given to double integral. You want to change it to the polar form. Okay, you know that x are cosine of the data, y are sine of the data, and we check it right away. Okay, this is it. That would be easy question because the domain must be, region must be a nice one. Okay, it's mostly a circle, semicircle. So this is question number 2. You want to use polar form to evaluate, okay? Evaluate. You want to evaluate the integral. Evaluate the integral by converting, or by using, okay? Converting to the polar coordinate, okay? Polar form or polar coordinates. Polar form. That's it, part 1. Part 1, this is your integral, 0 to 2. Okay, 0 to 2, 0 to radical 4 minus x squared, and the square root of x squared plus y squared, dy dx. Okay, your job is just changing the region first. The region, then for the function, you replace x by r cosine, y r sine. In this case, it's going to be just r squared. And then there is an extra r when you integrate it, okay? So check the domain first, okay? This is it. So your y is between 0 and 4 minus x squared, and your x is between 0 to 2. So you let y to be equal to radical 4 minus x squared. You know that this is a semicircle. You square it, 4 minus x squared. So x squared plus y squared equal to 4. Okay, so since y is just positive here, there's no positive negative, so it's going to be semicircle. So is the circle centered at 0 with the with the radius of a -2. So this is going to be the semicircle. I have to check the x to see if you are going to get all of them. You see your x is between 0 and 2. Since x is between 0 and 2, you are going to be interested only in the part of the circle or the semicircle, which is in the first quadrant. Okay, any question? It may be the full semicircle, or it may be just part. If this was a positive negative, so it's a full circle. That's it. So R is just the radius. The radius is between 0 and 2. Data, since you're using just a first quadrant, data is between 0 and pi half. That's it. Any question? So quickly you can identify it. So change the integral right away. This is it, 0 to 2, 0 to radical 4 minus x squared. Just repeat it. You can call it I if you don't want to repeat it. So it's going to be equal to the double integral. Remember, we integrate with respect to the R first, 0 to 2, then data, 0 to pi half. The function, you have to change it, a square root of x squared plus y squared would be R squared. If it's going to be something unusual, you replace x by R cosine of the data and y by R sine of it. But make sure you know it, an extra R, R, dr, d that. If things getting complicated, probably you miss this R. Okay, so that give you R. R times R would be R squared. So this is simply 0 to pi half. 0 to pi half, 0 to 2, okay, R squared. dr, d that. That's it, easy to integrate. Okay, so that's going to be the result. So the result is going to be 0 to pi half. Integral of R squared would be R cubed over 3. Then R going from 0 to 2 and the d that. We substitute 2 cubed would be 8, okay? So we substitute 0 to pi half, 2 cubed over 3 minus 0 d that. 2 cubed would be 8. So it's going to be 0 to pi half. We're integrating 0 to pi half. 0 to pi half, 8/3 of the data, d data. So it's going to be 8/3 data. Data is going to be between 0 and pi half. We just substitute the pi half. So 8/3 times pi half. You simplify it, 4 pi 10 is the final answer. Okay, so it's not bad. It can be done nicely. Okay, so this is where we use a semicircle, and in fact, it was just a quarter of the circle. So you may get both of them at the same time, the top and the bottom. Any question? So I do the second one. It's very much similar. Look at this. It's a negative 2 to 2, but a negative radical 4 minus y squared to the radical 4 minus y squared. So they're using the top and the bottom of the circle. So that's a full circle. Okay, so going to the part 2, part B. Okay, so what is going to be part B? In part B, we want to find this integral, negative 2 to 2. Okay, negative square root of 4 minus y squared. And that's a radical 4 minus y squared. The function is e to the negative x squared plus y squared. And the dx and the dy. That's it. Quickly, you find out that in this case, you are going to use the full circle. Okay, check this. So this is x. So x is between negative square root of 4 minus y squared and the positive. And your y is up and down. That's it. So you focus on this part to get the origin. So your x is equal to the positive negative, top and the bottom. If you square it, x squared, it's going to be just 4 minus y squared. And that gives you x squared plus y squared equal to the 4. It's a circle. Circle centered at 0 and the radius of 2. You have the positive negative, so you have the full circle. Okay, so this is what you have for your region. So it's 0, 2, -2, 2, -2. So this is going to be the region. Okay, that's a -2, 2. That's a +2, -2. So as you can see, positive, negative, and we have a -2 and 2. So it's going to be full circle. Okay, so R is just the radius is going to be between 0 and 2. And since you're using full circle, data is going to be between 0 and 2 pi. That's it. You have to switch the function. Again, you have x squared plus y squared, which is r squared. Otherwise, you replace the x by r cosine of the data, y by r sine of the data. You simplify it to get the function y. This is clear and easy. Okay, there you are. So we start with the integral. You can call it I if you don't want to repeat it. So I in polar form. Okay, in polar form, r going from 0 to 2, data going from 0 to 2 pi. You switch the function, it's e to the negative r squared. Then don't miss it, extra r, dr, d dot. That's it. So that extra r will help you because this is e to the negative r squared. Okay, so this is what we have, 0 to 2 pi, 0 to 2, r, e to the negative r squared, dr, d dot. See, after you do substitution, if you take the u to be negative r squared, your du would be negative 2r dr. So you need a -2 here, or just use the u substitute. I use the shortcut. So I want to put a -2 over here, so I divide the outside by 2. So this is the way I'm going to rewrite it, -1/2, integral 0 to 2 pi, integral 0 to 2. Now I put the -2 here, -2r e to the negative r squared, dr deta. So this would be like e to the u. Exponential function would be exponential function. It's e to the negative u. Okay, so this is it, -1/2, 0 to 2 pi. And we integrate over here. So the integral would be e to the negative r squared. And going from 0 to 2, and then deta. Okay, so this is going to be the case. So just substitute and just integrate. So it's going to be -1/2, 0 to 2 pi. If you put the r equal to 2, so that gives you e to the -4. If you put the 0, e to the 0, then deta. E to the -4, you can keep it, or you can use your calculator to get this number. And e to the 0 would be, okay, e to the 0 would be just 1. So this is what we have. It's going to be -1/2. So these are all numbers. I'm going to pull them out. It's e to the -4 minus 1 and 0 to 2 pi d dot. So it's going to be -1/2, okay, e to the -4 minus 1 data going from 0 to 2 pi. So we substitute 2 pi. So that gives me -1/2 e to the -4 minus 1 times 2 pi. 2 and 2 would cancel out. You can use your calculator if you like. But otherwise, you can multiply it if you like. That gives you pi minus pi e to the -4. Or calculate. Give you the final answer. Okay, so the domain, it cannot be something bad. It's all, circular, semicircular. There is one like, it's going to be like the slice of the pizza. That would take times. I'm not going to give you that domain. Okay, so it's going to be a straightforward, just to check it and be able to get it right away. Okay, so that's part B. So another one is very similar. This is a problem in your book that I wanted to see. You see the third one is this one. The domain is very much like the one we did. 0 to 2, 0 to a square root of 4 minus x squared. This is the function. Okay, that function is one that we want to see, 1 plus x squared plus y squared to the 3. Okay, let's do this one quickly. Again, that give you an idea of the type of the problem that you may see for the polar coordinates. Okay, so this would be 2c. And the integral in question is 0 to 2. Okay, 0 to 2, 0 to radical 4 minus x squared. And you have the dy and dx. And this is 1 plus x squared plus y squared. Everything to the 3 halves. This is your function. Again, the function is nice to convert because that gives you 1 plus r squared. And the region is nice. You see 0 to radical 4 minus x squared. It's a semicircle. The use 0 to 2 is going to be a quarter of a circle, like the first one. Okay, so there you are. Y is between 0 and 4 minus x squared, and the x between 0 and 2. So you let equal to and get the circle. Okay, as we did it for all of them, this is it. So that gives us x squared plus y squared equal to 4. So it's like the first part. Since using only y, it's a semicircle. Okay, radius 2. So that's a 2, negative 2, and the top 2. So this is going to be the semicircle. But x is between 0 and 2. X is between 0 and 2, so we are going to be interested in this quarter only. That's it. R is the radius between 0 and 2. And the data is only in the first quadrant. It's going to be between 0 and pi. That's it. So the region is like the first part that we did. Okay, so we are ready to give you the integral. Any question? So call the original one I. So now we are going to have a double integral. Our R is between 0 and 2. And the data is between 0 and pi half. The function is 1 over 1 plus x squared plus y squared would be just r squared. And raise it to the 3 half. And remember extra r, that would be so helpful here. dr, d that. That's it. To integrate it, you move this one up and use substitution, everything is provided. Okay, so it's going to be 0 to pi half. That's going to be 0 to 2. So we have 1 plus r squared to the negative 3 half times r dr, then the d that. Again, you take this one to be u prime would be, you see, u prime or du would be 2r dr. So you need a 2 here. You multiply and divide by 2 to create the du and then integrate. Or you can do the u substitution altogether. So this is it. I divide by 2 the outside, 0 to pi half, and I bring inside a 2. So now I have 2r dr and the d that. As you can see, this is going to be the du. So it's like u to the negative 3 half. You add 1 unit to the top, and then you about 1 half. 1 plus r squared to the negative 3 half plus 1. That gives a negative half. Okay, I'm sorry, I have this integral from 0 to pi half. Okay, I should have that integral. I haven't done. See, this is 0 to 2. I just rewrite it. I didn't integrate it. So that's a 0 to 2. Now we integrated. Now r going from 0 to 2, and then the d that. Okay, you can substitute 2 and the 0 to get this one done. So this is going to be integral from 0 to pi half. If you substitute 2, so that give you 1 plus 2 squared, which is 4. 4 and 1 would be 5. So that give you 5 to the negative half. Okay, minus. If you substitute 0, so that just give you 1. Okay, this is going to be 1/2 of the 5 to the negative 1/2. And that's a 1/2 again. It's not a nice number. Okay, you have to write it down. You can use your calculator or write it down in the radical form. So basically, this is it. Is going to be, you see, it's going to be 1/2 of 1 over radical 5 minus 1 integral from 0 to pi half d data. Okay, so it's going to be 1/2 1 over radical 5 minus 1 data from 0 to pi half. If you substitute the pi half, that gives you the final answer. Okay, so the situation I'm going to have is simply you get a 1/2 times 1 over radical 5 minus 1 times the pi half. Okay, I think I did everything all right. That's a 1/2. Then I substitute, yeah, you know, you can use your calculator, just write it down as 1 over radical 5 minus 1 pi 4. So this will be the final answer. You can double check it yourself. So that is polar coordinates, okay? So as you can see, the domain are nicely would be given. It must be a kind of a symmetric domain, circle, semicircle. You cannot do it for arbitrary domain. So just make sure that you switch the function as well, and then you'll be able to do it for us. Okay, so that was polar coordinates. Any question? Now we go to the surface area. Okay, we're going to have a couple of, we give you one, we have two nice one over here. Okay, how we're going to find the area of a given surface. This is question number 3. It's two problems, okay, that we're going to have. So this is number 3. You want to find the surface area, 2 cases, part of the paraboloid. We did this one during the lecture, okay, but I just explain it quickly again. The region is between 2 surfaces, okay, and you have to find the kind of cross-section type. And the second one is going to be, you have a surface area, a part of the surface area that's connected, bonded by a surface and a triangle, okay? So these surface area problem are not difficult, but sometimes you have to be very careful to pick the limit of integrations, okay? So I'm going to do both of them for you. Let me give you one on this test and one on the final. Just remind you the formula that we are going to use, and then we do it. So the next topic is going to be surface area. Okay. So this is going to be our next topics, number 3. Surface area. Surface area. So you have to know the formula. You see area of a surface is a double integral. Okay, double integral on a domain in the region that you're going to be given of this function. 1 plus partial derivative of f respect to the x squared, partial derivative of f respect to the y squared, and the dA. So it's a double integral of this function. You write it down first, then you decide how you're going to integrate it. Sometimes you may have to use polar coordinates. So you have to decide it yourself, okay, to get these numbers. So we're going to do the part 1 of this problem. So the part 1 is you want to find the area. Okay, find the area the area of this paraboloid. Okay, that's it. Paraboloid with the equation of z equal to 1 minus x squared minus y squared that lies above this plane. Above, okay, the plane z equal to, okay, z equal to the -2. We get this one done, okay? So you got to be careful because when you're integrating in two-dimensional, okay, double integral. So to do the double integral one, your region is going to be, okay, a projection of that three-dimensional solid or the three-dimensional region that we're going to have into the XY coordinates. So you got to be careful to find it. If you have one z, you let z equal to the 0, you drop the function in two-dimensional. If you have two z like this, you have to find the intersection, okay? Be careful about this one. Okay, so this is the way we're going to do it. Solution, you have to find this intersection first. So this is it, z equal to the 1 minus x squared minus y squared, and z equal to the -2. Okay, to get in the two-dimensional, you should have an equation in x and y. So you let them equal to each other, 1 minus x squared minus y squared equal to the -2. And you simplify it a little bit to get what type of region do you have. Of course, you know, you can, okay, you can move the 1 to the other side. And so that give you -x squared, -y squared equal to the -2 minus 1, which is going to be a -3. And you multiply everything by a negative sign to get what you need. You see, this is going to be the one. So this is going to be the projection. This is the region that you're going to integrate, okay, on. It's a projection of that part, okay, that you talk about it into two-dimensional. And so the d that you have to integrate is going to be just the circle centered at 0 with the radius of radical 3. So this is your d, x comma y, when x squared plus y squared equal to the 3. You see, since your region is a circle, so you better do your integration in polar form automatically. So instead of using the circle in two-dimensional, use the circle in polar form. So what is this circle in polar form? Okay, so this is it. You can graph it or just talk. You see, this is the circle that you're going to have. This is a circle centered at 0, and the radius is radical 3, negative radical 3, up, down. So this is what you have. This is going to be your, okay, circle. So you quickly can find R, the radius is between 0 and radical 3. And you can find your data, which is going to be between 0 and 2 pi. You see, that's the situation you're going to have. So this is the fact that you have to know it yourself, that you have to change it. Okay, now go back, form the integral, and just then change it to the polar form, and then with that. Any question? So there you are. The function is z. Z is equal to the f of x or y, if you like, and this is 1 minus x squared minus y squared. Get the partials. The partial respect to the x would be just negative 2x. The partial respect to the y would be negative 2y. Okay, so form A of S. It's a double integral on the d. Remember, this is it. So that make it to the square root of 1 plus a negative 2x squared plus a negative 2y squared and the d of A. So that give you 4x squared and the 4y squared. So it's a double integral. Okay, this is it. Going to be double integral, but you have 1 plus 1 plus 4x squared plus 4y squared, and the d of the area. So you better factor out the 4 because you want to change it to the polar coordinates. So it's a 1 plus 4 times x squared plus y squared. Okay, dA. As you can see, this integral is not easy to find, or you cannot do it. But you have to change it to the polar form. You know the polar form, you already done, r between 0 and radical 3, there are between 0 to pi. You have to change this function into the polar form. That's easy because x squared plus y squared is just r squared. Okay, so I'm going to go to the next page and continue. Any question? So you must do it yourself, that it can be done on polar form. Otherwise, we can't do it. So we continue. I'm going to change that one. So this is it. We are interested in the area of the surface. Now the integral would be in polar form. You written r radius is between 0 and radical 3. Data is between 0 and 2 pi. The function is 1 over 1 plus 4r squared, because x squared plus y squared is r squared. Then remember extra r, dr, d that. This is how you integrate this. Nicely done. Your substitution will give you value. So it's going to be 0 to 2 pi, 0 to 2 pi, 0 to radical 3. And this would be 1 plus 4r squared, as we did it just minutes ago. Okay, that's going to be r dr d that. You take this one to be u, then you need the u prime. Okay, if you take the u to be 1 plus 4r squared, so your du would be 8r dr. So you need an 8. So you divide the outside by 8. Okay, 0 to 2 pi. And you multiply the first one, inside one, by 8. So 1 plus 4r squared to the half. And you have 8r dr d that. So this would be like u to the half. See this part? It's like integrating u to the half. And you know that's going to be u to the 3 half, over the 3. Again, you have to do this in short form, not to make it more complicated. So it's a 1/8, 0 to 2 pi. You integrate, that give you 1 plus 4r squared to the 3 halves, over the 3 halves, all going from 0 to radical 3, and then d that. And that's going to be nice number. When you substitute, you take out of the 3 half, make it 2/3, bring it out. 1/8, 2/3, 0 to 2 pi. And this would be what? 1 plus 4r squared. To the 3 half, going from 0 to radical 3d that. You substitute, you get two numbers. You can simplify this. That give you 112. 112, okay, now 0 to 2 pi. These numbers, if you put the r equal to the radical 3 squared would be 3, 3 times 4, 12, 12 and 1, 13. So that give you 13 to the 3 half. Minus, if you put the 0, that give you just 1 to the 3 half. 1 to the 3 half. D that. Okay. These cannot be simplified. You can use your calculator if you like. Otherwise, this is the way you write it down, 112. You bring this out. If you don't want to use calculator, this would be 13, square root of 13 minus 1. And integral from 0 to 2 pi d that. Integral of d data would be just data. So it's a 112, 13 radical 13 minus 1 times data between 0 and 2 pi. You just substitute 2 pi and then you're done. So 112, 13 radical 13 minus 1 times 2 pi. Simplify 2 and 12, find an answer. is going to be, okay, that give you 6. It is 13, radical 13 minus 1 times pi over 6. This gives you the final answer. Okay. So it's a very popular problem. They just sometimes they change the numbers and they give you this. So be prepared to be able to do it. Okay, so that gives you an idea how we take care of these kind of area problems. Okay, so that's a part 1. The part 2 is not difficult. It's a little bit messy, but it can be done. So we can check that one too to almost to see that how we're going to handle that. Okay, that triangle regions. Okay, any question? So that's a very popular problem. Make sure don't miss it. You have to intersect it. Most of the people, they don't do it. You see, the way they do it is this. The way they do it, they let z equal to the 0. They consider x squared plus y squared equal to the 1 as a unit circle. They consider the radius to be between 0 and 1, the area between 0 and 2 pi, which is not correct. There is a z equal to -2 here. Okay, when it's a 2 z's, you have to intersect it. Okay, but in the second one, you have only 1 z. You see, look at this one. Part of this surface. Okay, quickly we solve for z. We have the z. We let it equal to 0. We drop it down, and then we check it. Okay, so let's check this one too. So that would be part 2. Again, your experience dealing with that triangle is important for us, okay? But it's the integral of a surface area. The numbers are messy. You can use your calculator, okay? So this would be 3b. 3b, this is the problem. You want to find the surface area, okay? Find the area of the part of this graph, part of the surface. Surface is given by this equation, 2y plus 4z minus x squared equal to the 5. Okay, want to do this one that lies above. Okay, above this triangle. With the following vertices. These are the vertices 0, 0, 2, 0, and 2, 4. This is it. So it's very standard because you have only 1 z. You solve for z, that give you the function. Okay. So that give you the function. Use that z equal to the 0. You have the region. The region is a triangle. Okay. So this is a kind of a standard form. So what we're going to do is you solve for z to get the surface of each function. You need one function to differentiate. In the previous one, we have to use the cross-section type. Okay, so this is it. Solve for z. So I have 2y plus 4z minus x squared equal to the 5. So 4z is equal to the 5 minus 2y plus x squared. You divide by 4. So z would be 5 quarters minus 2 quarters of y plus a quarter of x squared. You simplify these two. So you are going to deal with the surface of this. So it's going to be 1/2 of y plus a quarter of x squared. You see, this is your function. You have to find the partial of this. Okay, so this is going to be your f of x, y. So you get a partial of f sub x. F sub x would be what? Would be a quarter times 2x. You simplify that, give 1/2 of x. This is f sub x. You get f sub y, derivative respect to the y, which is easy. That gives -1/2. -1/2. Okay, so the surface area formula, A of S is equal to the double integral region. Region is a triangle. Okay, triangle of this 1 plus f sub x squared plus f sub y squared. Okay, y squared and the dA. So you bring this to see what the situation is going to be. It's going to be 1 plus, substitute, 1/2 of x squared plus -1/2 squared. E of the area. So you end up with this integral. Okay, it's going to be 1 plus 1/4 of x squared and plus 1/4. So combine the like terms, you have 1 and 1/4 that give it 3/4 or 5/4. So your A of S would be this integral. The double integral of 5/4 plus 1/4 of x squared dA. You see, you have to find this one. So from now on, it's a new problem. It's a double integral on a triangle. So you have to graph the triangle to see, because you have to find the limit of integration for your x and the y. How we're going to take care of the triangle? Okay, is a type 1, type 2. So go and graph the triangle. Any question? So the formula, you see the difference between this one and the other one is just cross-section type. For the first part, we have 2 z's. That's why we intersect them to get the result. And for this one, we have only one function. Okay, so there you are. Graph the triangle. The vertices are 0, 0, 2, 0, 2, 4. Let's see what we have. Okay, this is it. So 0, 0. This is going to be 0, 0. Then you have 2, 0. 1, 2. 2, 0. Okay, then you have 2, 4. 4, 1, 2, 3, 4. 4. Okay, that's your 4. So if you get this line, okay, that gives you a triangle. So this is going to be the triangle in question. Okay, and so you have to check what region are going to consider for the triangle. Go to the right, to the left, so your x is between 0 and 2. Then to get the y, you go up and down. You see up, down, up, down, up, down. So y is going to be greater than or equal to 0. You have to find the other parts. Okay. And to find the other part is not difficult. This is from 0, 0 to 2, 4. If you have difficulty, you can use the formula for the slope to find it. But in this case, it's easy because it's a line passing through the origin with the what is going to be the slope. See, for the slope is the right. It's going to be what? It's going to be rise, run. The rise of 4, the run of 2. So the slope is 2. So the graph is going to be y equal to the 2x. Okay, if you have difficulty, this is 0, 0, and this point is 2 and 4. You get the slope y2 minus, you see this is 2 and 4. And the slope would be y2 minus y1 divided by x2 minus x1, which is 4 over 2, which is 2. So that's why you get y equal to the 2x. Okay, so this is it, y between 0 and 2x. So this is the limit of your integration. You go back and you just use double integral on this region, like on your quiz. Okay, so there you are, A of S. Now it's going to be double integral, y between 0 and 2x, x between 0 and 1, And the term that you are going to integrate, remember, it was what? It's a 5/4. 5/4 plus a quarter times x squared, but integrate respect to the y, then integrate respect to the x. Nicely can be done, otherwise it's impossible. We integrate respect to the y, so that give you only y. Then that create du prime for the second part. So it's going to be 0 to 1. Okay, we integrate respect to the y, so that give it just y. 5/4 plus, okay, a quarter times x squared. And this is it, and then y going from 0 to 2x. When you're done, you take the dx. If you bring it down, so that gives you 0 to 1, just 2x. The square root of 5/4 plus a quarter of x squared. Okay, this is it, dx. Okay, y equal to the 0 would be the 1. Okay, any question? Yes.
Is there supposed to be a 1/4 y in the square root? Or do we drop it?
Where was the 1/4?
After the 1/4 x squared.
No, we
No?
simplified. Remember, that was 1 plus a quarter.
Okay.
1 plus a quarter would be 5/4.
Oh, yeah.
See, we already
Okay.
simplified.
never mind.
Okay, that's it. And now we want to integrate this one, change it and use substitution. 2x times 5/4 plus a quarter of x squared to the half dx. Now we take this one to be u. You see, your u would be your du. It's a 5/4 plus a quarter times x squared. So the du would be 2/4 of x, which is 1/2 of x. So you need a 1/2 to get that u prime to x. Okay, so what I'm going to do is I'm going to multiply it by 2, then divide by 2. You see, this is the way I do it. So multiply by 2, divide by 2, that give you half a 2x times a 5/4 plus a quarter of x squared. It's a messy. You can use your substitution if you like yourself. Okay, so I have to bring these two out. Then the rest is going to be 4 times 0 to 1. This is it, 5/4 plus a quarter of x squared. Then I have the 1/2 of x dx. You see, this is now du. And of course, this is to the 1/2. Now I integrated only u to the half, which is going to be u to the 3/2 over the 3. Okay, so the final answer is 4 times 5/4 plus a quarter times x squared to the 3/2. Okay, divided by 3/2, going from 0 to 1. So use the reciprocal of the 3/2, which is a 2/3. And this is it, 5/4 plus a quarter of x squared to the 3/2 plus 0 to 1. You have to use your calculator if you want the nice number. Okay, if you don't have the nice number, this is going to be 2 times 4 would be 8. So we get the 8/3. Okay, so we get the 8/3. See if I have the numbers for this one. I don't have it. Okay, you can use your, or I have it. You can use your calculator to give these numbers really. Okay, it's going to be 8/3. It's a 5/4 plus a quarter of x squared to the 3/2 from 0 to 1. If you put 1, that give it, you have to use your calculator to get this number. This one problem in your book, just wanted to see it. Okay, so surface area problem, okay, you got to be patient to be able to take care of it. It's not difficult, but you are going to have surface integral at the end of the course, which is going to be the same thing. Okay, so if you have a true curve, make sure you get the cross section first. If you have this one, which is going to be just an easy case, okay, we give you something, the region is going to be easier to handle, but it's not bad to know the triangle region. Okay, that's it. I give you a break. We come back. We do a couple of triple integrals. Okay, so we need to do something in cylindrical coordinate, spherical coordinate. Those are going to be easier problem to handle. Okay, and then finish. If you haven't been able to finish it, of course, I post the solution of all of them. Okay, nothing to worry about. Okay, so we'll have a short break, come back, and we continue taking care of this.
I have a question on number
Yes.
2.
Yeah.
I just had a quick question because when we converted the polar, we
Mhm.
said that r is r squared
Yeah.
in the square root. But I don't understand why we did that if r is equal to the square root of x squared plus y squared, and we
Oh,
already
you
have
can,
it.
yeah, you can do that.
Oh, okay, so we don't have to do this, we can
No,
just go
no,
straight here.
Yeah. yeah,
Okay,
yeah.
I was,
I just want to explain.
okay, got it. Thank you.
Just remind you that this is the way we do it.
Okay,
But yes, or.
okay, sounds good.
But the situation like the other day that we did, you see, if you have something like x squared plus y,
Mhm.
then you
Right.
have to really substitute.
Yes. Okay,
Okay, so make sure to remember that in that case, you substitute x equal to the r cosine of the theta
Mhm.
and y equal to the r sine of the theta, you simplify it. Be
Okay.
patient, just do it, simplify it.
Right,
There's going to be a connection, okay, nothing to worry about.
okay, got it. Thank you.
Okay, so let's do the first step. Okay, using a cylindrical and a spherical coordinate type of problems. Okay, we have. So, for example, we have this group number 7 cylindrical coordinates. Okay, these are kind of new. So this go to the number 7. What we would like to do, we would like to use cylindrical coordinate. Okay, give me one cylindrical coordinates to evaluate the integral. Okay, to evaluate each integral. Okay, you know that the formula is going to be the case that you are going to have this is it. You are going to have a triple integral. This is going to be a triple one f of x, y, z, dv. Okay, on the given domain, if you like. If you want to do the cylindrical one is you change the x and the y into the polar coordinate, and you keep the z as is. So you are going to have a two-dimensional in R and the data. Okay, so your data is going to be something like, okay, your R would be something between R1 and R2, and the data between data 1 and data 2. Okay, Z would be constant. Z would be fixed. Okay, Z1 and Z2. And in the case of the function, you change the X and the Y again into the polar coordinates. So X is going to be R cosine of the data, R sine of the data, keep the Z as is. That extra part, R, dZ, dr, d that. So it's very similar to the polar coordinates because you keep the Z constant, and so you have to just identify your region in two-dimensional. Two-dimensional is going to be just polar coordinates. So circle, semicircle, okay, those type of ideas. So it's very much similar. Okay, so we do the part 1. This is the function. You will see that it's like the one that we did before. You see, look at this. Before reading the rest, you see, you consider this one first. As you can see, we did it before. Y equal to the radical 4 minus x squared, just a semicircle. Okay, from -2 to 2. So that would be the polar form. So what is going to be the z part? They give another one, 0 to 1 over, okay, x squared plus y squared. Z can be a function of R and data. So if you replace x squared plus y squared by R squared, then you 1 over R squared. They give you the function. You see, this is your function. Again, this function can nicely change into the R, polar coordinate, and the dz, dy, dx. Okay, so it's very much like the polar coordinates. So what you have to do is, again, you have to put these together to see what will happen into the two-dimensional, okay? So as you can see, your x is between -2 and 2, and your y is between 0 and 4 minus x squared, okay? And your z is between 0 and 1 over, okay, x squared plus y squared. You have to find out the projection in two-dimensional first, okay, as we did it before. For the polar form, y equal to the 4 minus x squared, u squared. That give you your circle, x squared plus y squared to the 4. Okay, so you get a circle. You don't have positive, negative. So this is going to be a semicircle with the radius of 2. You see, this is a -2 and 2. And this is going to be your circle. You check the x is between -2 and 2, so you have the full, okay, full semicircle, if you like the upper part. Any question? So since it's not positive, negative, it's going to be just a semicircle. Since it's a -2 and 2, is going to be the full semicircle. If it was 0 to 2, it would be just first quadrant, okay? So quickly you can identify the range for your polar part. So the radius is r, which is between 0 and 2. And data is going to be semicircle, which is between 0 and pi. Okay, that's it. So you have to tell us what will happen to your z. Okay, you go to the z here. It's not a fixed number, so we have to change it to the r and the data. And that would be easily done, okay? So as you can see, you say that this is it. So you replace x squared plus y squared by r squared. So your z is going to be between 0 and 1 over r squared. Because z must be between two numbers, or it must be between, okay, a function of r and that. There you are. So we change everything. Now we can switch the integral and just do it. So the given integral, you call it I, is going to be equal to, now the triple. So your z goes from 0 to 1 over r squared. Middle one is r. Okay, your r is going from 0 to 2. And you get the data, which is 0 and pi. Function, this is your function. Radical x squared plus y squared is just r. Okay, so this is just r, or radical r squared. R, and remember that extension that we have. So it's going to be r dz, dr, d that. Okay, r dz. Okay, this is it. R dz, dr, d that. Like the the polar coordinates. That's it. Easy integral to apply. This would be r squared, and then keep you going. So it's going to be 0 to pi. It's not this difficult integral. 0 to 2, 0 to 1 over r squared. Then you go with the r squared, dz, dr, d that. Okay, integrate respect to the z, that give you r squared z. So it's going to be equal to the 0 to pi, 0 to 2. Okay, r squared z, but z going from 0 to 1 over r squared, and the dr and the d that. So if you put the z, so that gives you 0 to pi, okay, 0 to 2, is r squared z, but z is 1 over r squared. So it's r squared times 1 over r squared minus 0. And when you're done, you integrate in respect to the r and in respect to the that. So this would be simplified. So that gives you only 1. So we get integral of, okay, so we get integral from 0 to pi, 0 to 2, just a dr, d that. It's easy to operate, 0 to pi. So that gives you just r from 0 to 2, then d that. So that gives you 0 to pi, is 0 to pi, and that would be what? Just 2 d that. So that's going to be 2 data, 0 to pi. And if you substitute, that just give you 2 pi. So the final answer is going to be 2 pi. Okay, so the construction of this integral is not going to be difficult, okay? It would be easy to handle. Okay, you have one more, which is, this one is a little bit different. Okay, I explain this one too. It's going to be just the integration of the trigonometric part, which would be interesting to do. Okay, so I may give you one cylindrical one. Okay, let me just do this one. And you check the solution of all of them that I'm going to post for you. This takes time. Okay, let's just give you the second part, because there is a trigonometric type. Okay, this is it. And the second part is this one, 0 to 1. negative radical 1 minus x squared to the 0, and negative x squared minus y squared. So this is going to be the 7b. In 7b, you have this 0 to 1. Okay, negative 1 minus x squared, and that gives you 0. And you have, this is one of the problem in your book. This is going to be x squared plus y squared, and you have 21x y squared dz dy dx. You know, when we get to the integration part, it's a little bit messy. Just wanted to show you that you have to be patient, you'll be able to do it. That's it. So you have to tell us what would happen to your, okay, two-dimensional part. Nice, it's a semicircle. Semicircle, okay, so it can be done. And in case of the z, you see, you have to replace it. This give you negative r squared and r squared. And then you're able to do it, okay? So this is a situation I'm going to have. The polar format, the last one is x. So x is between 0 and 1. Your y is a semicircle. This is the y. Again, you bring it down to confirm that what you have. You see, this is the lower semicircle. You square it, that give you unit circle, x squared plus y squared equal to 1. So the region that you are going to integrating is this one. Okay. So you have the unit circle, so the radius is 1, 1, 1, 1. So this is going to be the, okay. This is going to be the, but this is the lower circle. You see negative, negative here. So you have to go down and pick this one. Okay. So what is the situation I'm going to have? So it's a lower part, but x is between 0 and 1. This is 0, this is 1. So this is the case, you see? That is the point about this problem. Okay, so it's a negative. So it's the bottom semicircle between 0 and this is a negative 1. You want it between 0 and 1, so you have to pick this part. Okay, so that's a little bit tricky. So your R is just the radius is between 0 and 1. So the important part is going to be what is going to be your data to get this part. Okay, your data, you've got to be careful because the direction that we're going on is this direction. So you have x from 0 to 1. You see, this is the one, the direction they're going to have. So your data is going to be here. If you go the actual direction on the top, is between 0 and pi half. But since you have the reverse direction, so your data is going to be between negative pi half and 0. Okay, so this is making it a little bit tricky. You've got to be careful. Okay, now we are ready. We are ready to integrate it because these are not going to be troubling because they are r squared. Okay, so what is going to be the result? There you are. I call it I. So we change it to the new format. This is it. Now you get much more to do for this. Okay, there you are. And the function, you have to change the function because you have the x and the y squared, so it will be 21. You replace the x by r cosine of the data, and you replace the y by r sine of the data. Remember extra r, and dz, dr, d data. That's the situation I'm going to have. Now z, negative x squared, y squared would be negative r squared to the r squared. And in the middle, we get the, okay, that's going to be your z. In the middle, we get the r, which is 0 to 1. And at the end, we get the data, which is a negative pi half. Negative pi half and 0. You see, that's your integral. So a little bit of simplification, r, that give r cubed. So you can pull out the 21. So 21 out, that give a negative pi half to the 0, 0 to 1, negative r squared to r squared. Now we get the r cubed. R cubed, cosine of the data, sine of the data. Then the dz, dr, d data. Okay, with respect to the z, that gives just z here. So it's going to be 21, negative pi half to 0, 0 to 1. So the integral would be just z, r cubed, cosine of the data. Oh, I'm sorry, there wasn't a square here, I missed it. It's a squared here because of the y squared. Yes, so make this one into the, we have r squared sine squared. So it's going to be r squared times r, so it's going to be r cubed, r to the 4th. This is r to the 4th. Okay, you get r squared, r. Okay, so this is r to the 4th. Cosine of the data, sine square of the data. Then z going from negative r squared to the r squared, and when you're done, it's a dr data. Okay, you substitute for the z, which give you more r here. So that gives you 21, negative pi half to 0. Okay, 0 to 1. Now you substitute for z, that give you r squared, r to the 4th. That make this one r to the 6th. See, that is going to be the case. We have r squared, okay? R squared times r to the 4th, that give r to the 6th. R to the 6th, cosine of the data, sine square of the data, minus, if you put the negative r squared. Negative r squared, that give you negative. That give you negative, okay, r to the 6th, cosine of the data, sine square of the data. When you're done, dr data. Any question? Both of them are the same. Okay, we substitute for the z. So this negative would be positive. So we like adding these two together, that give you a 2. So 21, negative pi half to the 0. Okay, 0 to 1. Then we get 2r to the 6. Cosine of the data, sine square of the data, d of the data. But, sorry, dr, d data. Now you are going to integrate with respect to the r, which is easy. 2r to the 6 would be 2r to the 7. So it's going to be 21, negative pi half to the 0, 2r to the 7 over 7. Okay, 2r to the 7 over 7. Okay, cosine of the data, sine square of the data, at r going from 0 to 1, then d data. If you replace r by 1, that gives you just 2, 7. You can put it out. So it's going to be 21 times 2, 7. 2, 7, integral of negative pi half to the 0, cosine of the data, sine square of the data, d data. Okay, any question? You put r equal to 1, that give you 2, 7. If you replace r by 0, that give you 0. I pull out the 2, 7, so I can simplify it now. I can simplify these two, so that give me 3 times 2, which is going to be equal to the 6. Okay, so you have to integrate 6, negative pi half to the 0, cosine of the data, sine square of the data, d data. Okay, the integral inside is easy to operate. because you take U substitution, you take the U to be sine of the data. Okay, du is cosine, you already got it. So it's like U squared. So that give you sine cube of data over 3, going from negative pi half to pi half, and you'll be able to find it. Okay, any question? So just use substitution. I go to the next page and find it. It says, as I told you, it's in the book. Just wanted to say it. Okay, but again, the one you have is straightforward one. See it to handle. So what it is, it's a 6. It's going to be 6 times sine cube of the data over 3, going from negative pi half to the 0. So this would simplify. So that give you 2 sine cubed of data going from negative pi half to the 0. If you put the 0, the sign of the 0 would be 0. So 2 sine cube of 0 minus 2 sine cube of a negative pi half. Sine of 0 is 0. So that gives you 0. Sine of the negative pi half is a negative 1. So that gives you negative 2 times negative 1 cubed. Negative 2 times negative 1, which is 2. So the result is going to be equal to 2. Just show you that it maybe seems to be complicated, but when you put them together, really, that's the role of this cylindrical coordinate. But the one that you see is maybe just straightforward, but this integral are all, as you can see, on a, on kind of a semicircle, circle that give you the result. Okay, so that was another one. So before giving you one on the spherical one, there is one more important problem. I just explained that one too. Okay, it's not difficult, but it's a very popular case. I give you number 5. It's kind of a volume problem. I ask you to use cylindrical coordinate to do it. Okay, that's number 5. Just to remind you that we give you one volume problem. Okay, so number 5, volume problem. You did the tetrahedron on your quiz. Maybe repeat it again, just read it. So what we'd like to do is we'd like to use the cylindrical coordinate. Use cylindrical coordinate. Cylindrical coordinates to find the volume. Okay, to find the volume. To find the volume of the solid. Of the solid bounded by. You see, it's bounded by this z equal to the. Bounded by z equal to the 9 minus x squared minus y squared, and z equal to the 0. If it's not 0, whatever it is, you have to intersect them together, remember. Now, you see the volume formula for the triple integral, we replace the function by 1. You have to remember this. Okay, the volume is going to be 1, 2, 3, just 1, nothing here. Okay, if you like 1, the dv over the given domain, whatever it is. So what you have to do is you have to find the limit for the z. If you have 2 z numbers, you see one of them is 0, the other one is 9 minus x squared minus y squared. So that's a range for the z from 0 to 9 minus x squared minus y squared. You have to write it down in xyz coordinate first, then change it. Then you replace the z by, you replace the z by 0 to get the projection of these, to get the projection in 2-dimensional, to be able to do it, So this is a situation we're going to have. So your Z is going to be between what? Your Z is going to be between 0, 9 minus x squared minus y squared. This is your first step for the Z. Okay? Then into dimensional, you have to see what you have and then change it to the polar form. What do you have? You replace the Z by 0 to drop it down. Okay? So the projection okay, onto XY plane. You let Z equal to the 0 or the intersection of these two, you see? So that gives you 9 minus x squared minus y squared equal to the 0. So that gives you x squared plus y squared equal to the 9. You see, if it was anything else, if it's Z equal to 1, you let it equal to 1. Like the example that I did during the lecture. So that gives you the projection. It's easy, you have a circle. Okay, we get a circle with a radius 3. Okay, that's it. So that's a negative 3, 3, the top 3 and 3. And it's a full circle. So the polar format of the circle is the radius is between 0 and 3. And your data is between 0 and 2 pi. That's it. So you just find your volume in, okay, in the polar form or cylindrical coordinate. See, the volume would be 1, 2, 3. This would be the Z, change of the Z. What is Z? Z is from 0. Okay, 9 minus x squared minus y squared. That gives 9 minus r squared. That's a Z. Okay, 9 minus x squared. Because you change it to the cylindrical coordinate, so this must be 9 minus x squared minus y squared. Okay, then in the middle, we get the r, 0 to 3. And at the end, we do the data. The function is just 1. But remember extra term, r, dz, dr, dθ. This is the way you find it. Okay, again, be careful. If this z is not 0, you have to find the intersection first. Your circle would be different. Okay, the integral is very easy now because you integrate respect to the z first. So that gives you 0 to 2 pi. Okay, 0 to 3. So integrate that gives you z rz. But z going from 0 to 9 minus r squared. Then you come back and you get the dr dθ. So if you substitute, so that gives you 0 to 2 pi. Okay. We have 0 to 3. We substitute. Instead of the z, you write 9 minus r squared. So it's going to be r times 9 minus r squared. Then the dr dθ. You multiply and you integrate. So you end up with the 0 to 2 pi. Okay, 0 to 3. So it's a 9r minus r cubed. Dr dθ. Easily we can integrate it. Okay, integrate respect to the r. These are all just numbers, substitute the result. Are you done? So I integrate this one, 9r squared over 2 minus r to the 4th over 4, and just substituting those numbers. So it's equal to, okay, it's going to be equal to the integral from 0 to 2 pi. That gives me 9r squared over 2 minus, okay, r to the 4th over 4. And going from 0 to 3, then d that. Substitute is all number, okay. If you put the 3, that gives me 9 times 3 squared over 2 minus 3 to the 4th over 4. And the d that. So 3 squared, 9 times 9, 81. So that give you 81/2, and that would be 81/4 E data. Find the common denominator. Okay, common denominator would be 4, so that give you 0 to 2 pi. It's like 1/2 minus a quarter, so that give you a quarter again. Okay, so it's going to be 81/4 D data. So it's going to be 81/4 data from 0 to 2 pi. If you substitute 81/4 times 2 pi, simplify it, 81 pi/2 is the final answer. Okay, so that gives you the experience. Cylindrical coordinate is not difficult because in two-dimensional, you change it into the, okay, you change it to the polar coordinates. Okay, so I get time to do a spherical one for you, and then you can check the solutions that I will post. The spherical coordinate is going to be spherical for straightforward, 1. And there is only kind of one function that we deal with. Okay, so let's give you one. But you must make sure you get the formula all right. Okay, so this is the formula for the spherical one. Coordinates. Remember, you have this function to integrate f of x, y, z, dv over the w. So what you change is going to be, the change are going to be the function, and instead of the, it's like the polar coordinate. And instead of the r, we use the rho, okay, rho, data, and phi. So this is it. We change the function into the, and instead of the x, y, z, okay, we change it to the rho, data, and phi. Then we have extra term. You shouldn't miss this one. It's the rho squared sine of the phi. That's the extra term. Then what you do, you're just integrating with respect to the rho first, then phi, and at the end, that. And remember that the rho square is x squared plus y squared plus z squared. That's the situation we're going to have. This function must be a very typical function. You cannot use any function. Okay, and the famous one is this number 11. Want to integrate this 1, 2, 3. We did the one version of this. In fact, we did exactly the same one the other day. Okay, this is it. X squared plus y squared plus z squared dv. You want to do this one on the region. The region is a sphere. So where G is the unit sphere, unit sphere. Unit sphere means the equation for the G is x, y, z. You have x squared plus y squared plus z squared equal to 1. We give unit a sphere because that's very easy to handle. Okay, now the way we do it is this is it. You have to change the function. This is radical x squared plus y squared plus z squared would be rho. You have this extra 1 that you put it. So you have to get you drop it down in two-dimensional to see what's happening over this one. The radius is 1, so the rho is automatically between 0 and 1. You see, rho is between 0 and 1. If you replace the z by 0, you end up with the unit circle. So in a unit circle, the situation you're going to have your data is going to be between 0 and 2 pi. Remember, phi is the angle between two vectors. So it's between 0 and pi. Unless some restriction is given to, but otherwise, This is a situation that we're going to have, okay? So they have to give you either a sphere or a hemisphere to be able to change it. So we go back and we substitute here. We call it I. It's going to be 1, 2, 3. Rho is the radius, 0, 1. In the middle one, we do the phi, 0, pi. And outside, we do the data, 0 and 2 pi. Function is going to be e to the rho, because x squared plus y squared plus z squared is rho squared. Extra term, rho squared, okay, rho squared, sine of the phi. And then d of the rho, d of the phi, and the d of the data. Okay, we did this one during the lecture because you have to use the integration by parts. Okay, so we put them together and start integrating and then get the result. So you may need integration by parts. And we did this one before. Okay, so let's give it a solution. So this is what will happen. So we have 0 to 2 pi. Okay, 0 to 2 pi, 0 to pi, and 0 to 1. The function is rho square e to the rho. D rho. This is the one that you have to do first. And then when you're done, it's going to be the sine of the phi, d of the phi, d of the dot. Okay, as we did it the other day, you have to take this one out. Most of the time, you have to use the integration by parts. Okay, that tabular method. We did this one before, so I just give you the result. Okay, so just using the tabular method, if I have it, I can give you that. As we did it the other day, yeah. By integration by parts, this would be, this is rho squared. I'd use the table, remember. Minus 2 rho e to the rho. Okay, plus 2 e to the rho. It's going to be from 0 to 1. If you substitute, that gives you e minus 2. We did it the other day. Okay, tabular method. You may have rho e to the rho most of the time, which is easier to handle. So that would take care of this part. So the result is going to be, you integrate it 0 to 2 pi, 0 to pi, just this number, e to the negative 2, sine of the phi, d of the phi, d of the dot. E minus 2 is the number, take it out, and then integrate 0 to 2 pi, 0 to pi, sine of the phi, d of the phi first, and when you're done, you go with the d data. Now we take care of this integral. It's very easy. Integral of a sine is a negative cosine. So e to the negative 2, 0 to 2 pi, negative cosine of the phi, pi going from 0 to pi, and then d data. You substitute, it's going to be e minus 2, 0 to 2 pi. If you put the pi, that gives you negative cosine of the pi minus negative cosine of 0, then d data. Cosine of the pi is negative 1, cosine of the 0 is 1. So that gives you e minus 2, 0 to 2 pi, negative, negative, positive, negative, negative, positive, d dot. It's going to be 2. So e minus 2, 0 to 2 pi, 2 d dot. So that simply gives you e minus 2, 2 data going from 0 to 2 pi. If you substitute, E minus 2 times 2 pi is going to be the final answer. Okay, just make sure to bring your formulas, okay? That one page that you are able to bring in, bring the formula, just do these conversions correctly. Okay, I missed there's a 2 here, and I missed this 2. 2 data, yeah? It's 4. 2 times 2, 4. So if you like, it's equal to the 4 pi times E minus 2. Okay, that's it. So I post this, I have the solutions. I posted, there are 2 recordings that you can check. I want to upload this recording, but it's not going to be all the problems, okay? So if you want to see it, 2 recordings. One of them is practice quiz number 3 from that summer that we have. So some of the problems, polar coordinates and reversing the order are going to be on that practice quiz number 3. And there is one for the test. So you just check both of them. I will post it for you, part 1 and part 2. So check those 2. You can drop your lowest test. But don't count on it because these are going to be given on the final. So your final would be test 3 and quiz 4. So you better study this one and keep the solution for the final, okay? You are going to have 1 more section from this chapter and 3 sections from chapter 15. We give you the quiz 4 on that one, and then the final would get these 2 only. But remember, for this test, we give 1 question on that relative max, relative min. Don't miss it, bring the formula for the test 2. Okay, that's it. Have a good one, and you can start taking the test starting tomorrow, but otherwise, see you on Monday here for test number 3. Okay, that's it.